record that. Now that I'm recording, I'll go back over it for half a second here. G prime of 3, since we don't have the function, we just take the average rate of change on the interval surrounding it. So 20.5 minus 15.1 over 5 minus 1. It's feet cubed per minute, so feet cubed per minute squared, and it's the derivative of a rate, so it's telling us that that rate is increasing at 1.35 cubic feet per minute squared. All right, part B, write an integral expression that represents the total amount of grain added to the silo from t equals 0 to t equals 8. So what should that integral look like? If we want the total amount added from 0 to 8, that should be just be an integral from 0 to 8 of g of t. I mean, that's all you do to find the amount of something. If you're given a rate, is integrate from starting point to the ending point of that rate function. And then they want you to approximate that integral using a right Riemann sum with 4 subintervals. So our first subinterval coming from the right-hand side is 2 units long. So we'll say this is approximately equal to 2 times the height at the right endpoint, which is 22.7, plus the next one, which is 6 to 5. So that'd be 1 times the height on the right endpoint of that interval, which is 18.3. Next one should be 4 units from 5 to 1 with a height of 20.5. And then the last one should be 1 unit from 1 to 0 times the 15.1. And I don't know, what did that come out to be? Looks like that came out to be 160.8. Yeah. And that, if it asks for units, it doesn't, but that'd be cubic feet of grain. Real quick, I didn't go over the points. So the first one was worth 2 points. 1 was for the number, and 1 was for the interpretation with the units. And on the second one, 1 point for the expression, 1 point for setting up the sum, 1 point for getting the correct sum. Good? Yeah?
I have a question.
Okay.
So do you not need to do the b minus a over n, that thing?
For the right Riemann sum you're talking about?
Yeah.
You only use b minus a over n if these subintervals are equal. So you can do b minus, if this was 0 to 2, 2 to 4, 4 to 6, 6 to 8, they'd all be equal subintervals. So you can do b minus a over n. That'd tell you the length of each subinterval, and you can just multiply that by each of your data points that you needed to use. But since they're unequal subintervals, we just find the length of each one and multiply it by the height.
Okay.
Good?
Yeah.
Okay. Anybody else, any other questions on that? All right. Part C. Oh, fun. The grain in the silo is spoiling at a rate modeled by W of t, which is that fun function. We want to use our result from part B, so this 160.8 that we already got, to approximate the amount of unspoiled grain that remains in the silo at t equals 8. So we put in 160.8. We want to check our initial condition. At the beginning, the silo is empty. So if the silo hadn't been empty at the beginning, we'd have to include that value, but it says it was empty. So we know that through those 8 minutes, not hours, through those 8 minutes, 160.8 cubic feet were put in. And so we want to know how much of that spoils. So how are we going to figure out how much of that spoils with that W of t rate function? Should just be an integral from 0 to 8 of W of t to figure out how much spoils. And what did that come out to be? About 99 point something, 99.051497. And so all we need to do to figure out how much is left is take our 160.8, I think. Yeah, 160.8. and subtract the amount that spoils, and that gives us 61.749 cubic feet. Good or no? Any issues or questions on that one? That was worth 2 points, 1 point if you set up with the integral, and 1 point for this final answer. And then part D. So we want to know, is the amount of unspoiled grain in the silo increasing or decreasing at t equals 6? So how do we figure out if the amount of unspoiled grain is increasing or decreasing, given these two different rates that we've got? Yeah, we need to see if the value at g of 6 or the value at w of 6 is greater. Right, so we could look at the g of 6 minus the w of 6. If that was a positive value, then it would be increasing. If that's a negative value, then that would be decreasing. Right? So g of 6 was 18.3 according to the chart. And w of 6, you'd plug in and figure out what that is. It was 16.063173. This is positive, therefore it should be increasing. And that was worth 2 points. 1 point if you looked at g of 6 minus w of 6 or compared g of 6 and w of 6 in some way, and 1 point for increasing. Good. Any questions there on any of the grain silo problem? Everyone's good. Okay. Let's look at the snail. For the first part, we just want to find the acceleration of the snail. We're given the velocity function of the snail. So if we want the acceleration, that ought to be really slow because it's a snail, but also it ought to just be the derivative of the velocity. V prime of 5 is A of 5. Your calculator will tell you what the derivative of 1.4 natural log of 1 plus t squared is at 5. Hopefully it'll tell you that it is 0.538 462. That sound right to everybody?
Is there minimum sig figs that they would be looking for?
They are always requiring at least 3 decimals unless they state otherwise. Always okay. 3 or more. If you give them 2 decimals, you will not get the points. All right. Part B. We want to know what is the displacement of the snail over the interval 0 to 15. So if we're talking displacement, that's not total distance traveled. That's just a distance from where it started. How do you find displacement given a velocity function? You should know how to find displacement with a velocity function. You just have to integrate it, right? You integrate your velocity function from 0 to 15. That ought to tell you where it is, right? In relation to where it started. And what was that integral? Your calculator told you that that integral was 76.043074. 2 points for that. 1 for the integral, 1 for the answer. I think A and B should have been pretty easy there. I hope. Part C, we want to know when the snail's instantaneous velocity is equal to its average velocity. So first off, we're going to need to figure out what the average velocity of that snail is on those 15 minutes. Minutes? Minutes. Must be minutes. Snails don't move in seconds. I don't think they can do that. So how are we going to figure out the average velocity in those 15 minutes? we already had this integral of v of t from 0 to 15. All we have to do is divide it by 15 minus 0, right? Divide it by 15. Right, the average velocity is just 1 over 15 minus 0 times the integral from 0 to 15 of v of t dt. So 76.043074 divided by 15 gives you some number. Looks like that number is 5.069538. And then you're just going to set that equal to 1.4 natural log of 1 plus t squared. So that's the velocity function, and see where those two functions intersect each other. Yeah, your calculator will tell you that when you graph both of them. Graph y equals that, just that line, and then 1.4 ln 1 plus t squared. Or you can graph 1.4 ln 1 plus t squared and minus 5.069538, and then you can see where that has an x-intercept. Looks like that happened at t equals 6.031 minutes. Is that what you guys got for that? When you graph those and look for the intersection point? Yeah. That was worth 2 points. 1 for the average value, 1 for the answer. Good? Good? Serena, you good with that? Yeah? Okay. All right, part D, we have an ant. An ant arrives at the snail's starting position at t equals 12 and follows the snail's path. It travels in the same direction with a constant acceleration of 2 inches per minute per minute. The ant catches up to the snail at t equals 15 minutes. We know that at t equals 12, it is going b inches per minute. We want to find b. So what are we going to do to figure this out? How far does that ant go in those 3 minutes that it's walking? From 12 to 15, the ant must cover the same distance that the snail did in those 15 minutes, right? So how far did it go? Didn't we figure that out earlier in the problem? Yeah. 76.043074, right? The answer from part B. All right, we also know that the ant has a constant acceleration of 2 inches per minute per minute. So we're going to say the acceleration of the ant is 2. What is the velocity of the ant then? How do we get a velocity from an acceleration? An integral, right? So what's the integral of that? 2t plus some constant. And what is its displacement then? Its displacement of the ant ought to be t squared plus some constant times t. And we know what that displacement is if we integrate from 12 to 15, don't we? So if we evaluate that from 12 to 15, that should equal that 76.043074 value, right? That should allow us to figure out what this value of c is. Once we know what the c is, we can go back in and figure out what the velocity is. at 12. That makes sense to everybody? So what do you get if you simplify all this out? Plug in your 15, you end up with 225 plus 25c minus 144 plus 12c equals 76.043074. And that ought to tell you that c is 25.9. I don't agree with that. I disagree. 225 minus 144 is 81. So we're going to have 76.043 minus 81. And then we're going to need to divide that. That should be a plus there. But we're going to need to divide that by 3. So it's going to be like negative 1 something. Negative, according to the scoring guidelines, negative 1.652309. Does that setup make conceptual sense to everybody though? What we've done, we've integrated acceleration to get the velocity function. Then we've integrated the velocity on the time interval we know, 12 to 15. We know how far it went. So if we integrate the velocity from 12 to 15, we should be able to get this 76 value, and we should be able to solve for c. And if c is negative 1.652309, b, the velocity at 12, right, b of 12 ought to be 2 times t plus or minus 1.652309. 1.652309, which should be 22.348. That makes sense or no? Yeah? Anybody have any questions on that one? Sounds good. All right. Zoom people, you're all good?
Yeah.
Questions for it? Oh, the points for that one. There was 4 points for it. 1 point. Let's see. I did A, B, and C already. Yeah. Okay. So 1 point for getting a function to represent the ant's velocity. 1 point for a function to represent the displacement. 1 point for setting that displacement equal to the distance that ant traveled, and then 1 point for the final answer. Oh, that's not the final answer. 1 point for the final answer over here.